All right, so what we're going to be talking about here today is actually something that goes with the previous example, except it's even easier than what we did before. How is it easier? Well, what we're working with here are quadrantal angles. That means that whatever the terminal side is, it lies on one of the actual axes. Now, what does that mean for our trig functions? Well, if you look at it, for instance, if you look right over here, the terminal side is on the y-axis. That means that our radius and our y value are going to be the same thing. Now, you should be able to realize that just from looking at it. If you look over here, our radius and the x value will be the same thing. And then over here, the radius and the y value again will be the same thing. The only difference is that the radius will always be positive, but the x value might be negative. So on this one over here, the radius, whatever we use for our r value, will be positive. However, the actual x value will be negative. So the length is going to be the same thing. Now, even if you look at a problem and you forget about this, or you forget to think about this, you should be able to solve it out the exact same way as we did the other ones, but you'll find out that it actually simplifies a lot easier than the previous examples that we did. And I'll show you that right over here. All right, so here in example 2, the first thing that we're going to do is identify our x, y, and r, and then we're just going to throw it into the trig functions. So if we look, our x is going to be 0 because of the coordinate that we have right over here or right over here. Either one you can look at and get our x value. Now our y value, same thing, is going to be 6. What is our r value going to be? Now we should be able to look at the angle and realize that it's going to be the same as whatever y value we have. So our r should equal 6. But even if we don't remember that, we can still use our Pythagorean theorem, which is r equals the square root of x squared plus y squared. So we would say r equals the square root of 0 squared plus 6 squared. So that's just going to be the square root of 6 squared, or you could also say the square root of 36. So that's going to equal 6. So we were right. Our r value does equal 6. Now, throwing it into the trig functions, you can do very, very simply. So I just went ahead and copied down my trig functions from the previous example. And here we have y, r, x, r, y, and x. And we're just going to fill them in. Y equals 6, r equals 6. So that's going to simplify down to 1. X equals 0, r equals 6. That's going to simplify down to 0. Y equals 6, x equals 0. We cannot divide by 0, so that's going to be undefined. So we'll just say UND. Now let's flip all of these things over. 6 divided by 6 flipped over is still 6 divided by 6, which is going to equal 1. Once again, if we flip over 0 divided by 6, we're going to get 6 divided by 0. That, again, we cannot divide by 0, so that's going to be undefined. This last one is going to be 6 divided by 0 flipped over, so that'll be 0 divided by 6. Now 0 divided by any number is just going to be 0. So those are our 6 trig functions. As you can see, they were actually easier than the trig functions that we had before. So if you ever see your terminal side on one of the axes, you should immediately think, hey, this is going to be super easy. Let's try out the guided practice. Now this is the point in the video that I would like you to pause and try this by yourself. Now you should be able to get this by yourself, so please give it a shot. Thank you so much for pausing, and I know you did because you're an amazing student or parent watching this video. Now, if we were to draw this out, what would this look like? We know a couple things. We know that our initial side is going to be right along that line there because our initial side is always there. Now, where is our terminal side? Well, the terminal side is going to be wherever the point is. Now, there is a point at -2, 0. So -2, 0 is about right there, let's say. That means this is going to be our terminal side, and this is going to be our angle right over there. So what can we tell about this? Well, our r value is going to be the exact same thing as our x value, except it's going to be positive because our radius is always going to be positive. So if we ever have one of these quadrantal angles, just realize that whatever the x or y value is, if it's negative, you're just going to switch it over to a positive to get your r value. So to find out our trig functions, the first thing that we're going to do, we are going to identify our x, y, and r values. X equals -2, y equals 0. Now, as we figured out already, our r value should just equal 2, the positive representation of our x value. But we could figure that out with our Pythagorean theorem anyways if we needed to. So that's going to be r equals the square root of x squared plus y squared. Now x equals -2, so that'll be -2 squared plus 0 squared on the inside of that radical. Same thing if we take off the 0 because it's 0 and we do -2 squared, that equals 4, so that'll be the square root of 4, which we know simplifies down to 2. So as we can see, we have confirmed that our r equals 2. So now we can just throw those into our trig functions. I have taken the liberty of literally copying this down from the previous example, and now we're just going to fill them in. Y over r will be 0 over negative. Y over r will just be 0 over 2, which of course will equal 0. X over r will equal -2 over 2, which will equal -1. Y over r will equal 0 over 2, which will equal 0. Now all we're going to do is use our reciprocals for the cosecant, secant, and cotangent functions. This will be 2 over 0, which we cannot divide by 0, so we will call this undefined. This will be 2 over -2, which will still just equal -1. And then, as you may have guessed, 2 over 0, that's just going to be undefined. So we have our 6 trig functions, and again, it was so much easier than our previous example.